Do you know how to find out the area of a triangle inscribed in the rectangle? In this video, we will learn that. So, Assalamu alaikum guys, welcome to NoorulRiazi and this is your mathematics teacher Nuruddin Qureshi. And in this video, we will learn how to find out the area of a triangle with different cases. So let's start with our first case in which base and height of a triangle is given. So let's understand first what is the base and height of a triangle. So let's assume a triangle with a base like this and a height given as this. So what is base here? So base is the side on which the triangle rests. So triangle is resting on this side, so we can assume that this is our base. Then we have height or altitude. So height or altitude is the length from the topmost point of a triangle to its lowermost point. So as you can see, this is the topmost point, this is the lowermost point. So it is the height of a triangle. Or by other definition, you can say it is the perpendicular line from its base to the opposite vertex. So as you can see, this is dropped from the opposite vertex, it is perpendicular to its base. So this is also height. Now the question arises, is it necessary that the lowermost side is always the base? No, this is not. So for three sides of the triangle, you can have three bases and three heights. So for example, if you have this is base 1, this is height 1. So for this base 2, this will be your height 2. And for this base 3, this will be your height 3. So for any pair of base and height, the area of a triangle is given as half into base into height. So now let's see an example. So for a triangle with the base of 8 and height of 5, the area of a triangle is half into base into height. So putting the value of base and height, we can get area is equal to half into 8 into 5, which is equal to 20. So 20 is the area of this triangle. Now let's move towards another case. So in our second case, we have two perpendicular sides of a triangle. So for a triangle which have two perpendicular sides, that means a right triangle. So for example, this is a triangle. These two sides are perpendicular to each other and this is side 1, this is side 2. So the area of a triangle is given as half into the product of two perpendicular sides. So for example, for a right triangle, we have sides given as 9 and 5. So the area of a triangle is given as half into product of two perpendicular sides. So area is half into 9 into 5. So area is given as 22.5. So now even our third case, we have two sides and an angle between them is given. So let's assume a triangle with sides A and B and an angle is given between them as C. So now as you know that area of a triangle is given as half into base into height. This is the height, but here height is not given. So you can consider this right triangle as given as this. So this is a right triangle. As you know that for sine theta, that is equal to perpendicular upon hypotenuse. So in this triangle, the perpendicular is height and the hypotenuse is given as B. So in this triangle for sine C, the perpendicular is given as the height and the hypotenuse is given as the base. So sine C can be given as height upon B. So height can be given as B into sine C. But also since the base is A, so putting the value of height and base in this equation, we can get area is equals to half into AB sine C. So for a triangle with two sides and an angle given them, so the area of a triangle is given as half into the product of the two sides into sine of the angle between them. So now let's see an example for a triangle with sides 8 and 6 and an angle between them of 30 degree. So according to the formula, area is given as half into AB into sine C. For here AB is 8 and 6 and C is 30 degrees. So putting the values, we will get area is equals to half into 6 into 8 into sine 30 degree. So the value of sine 30 degree is half and half into 6 into 8 is 24. So the area is given as 12. Now let's see our fourth case in which only three sides of a triangle is given. So let's assume these three sides as A, B and C. So here before finding the area, we have to find out the semi-perimeter of a triangle. What is semi-perimeter? That means half of the sum of all sides. So the semi-perimeter S is given as A plus B plus C upon 2. So the area of a triangle is given as under root s into s minus a into s minus b into s minus c, where a, b, c are the three sides of a triangle and s is the semi-perimeter of the triangle. So this formula is also called as Heron's formula. So now let's see its example. So we have a triangle with side 6, 4 and 8. So first of all, we will find out the semi-perimeter of a triangle. So that would be 4 plus 6 plus 8 upon 2. That means 9. And putting the value in the formula, we will get under root 9 into 9 minus 4 into 9 minus 6 into 9 minus 8, where 4, 6 and 8 are the three sides of the triangle and 9 is the semi-perimeter. So that will be equal to under root 9 into 5 into 3 into 2, or under root 270, or in other words we can say the area of a triangle is given as 3 under root 30. So now let's see the fifth case of the triangle, which is for the case of a equilateral triangle. So for any equilateral triangle, since all three sides and angles are same, so angles are given as 60, 60 and 60, and the sides are given as s, s and s. So for these three sides, the area of a triangle is given as area is equals to s square under root 3 upon 4, where s is any of the sides of equilateral triangle. So for example, we have a triangle with sides of 6, 6 and 6. So for area of a triangle, area is given as s square under root 3 upon 4. So putting the value of 6 in the place of s, we can get 6 square under root 3 upon 4, which is equal to 9 under root 3. So now let's see another case, the sixth case, which is for the triangle which is inscribed in a rectangle. So for any rectangle given as the dimensions of f and g, if a triangle is inscribed in it with its displacement given as w and v. So w is this displacement and v is this displacement. So the area of a triangle is given as f into g minus v into w upon 2. So f into g minus v into w divided by 2. So let's see an example for this case. So for a rectangle with the dimension of 12 and 11, we have a triangle inscribed in it with the displacement of 5 and 4. So the area of a triangle is given as f into g minus v into w upon 2. So putting the values of f, g, v and w, we will get 11 into 12 minus 4 into 5 upon 2. So 11 into 12 is 132 and 4 into 5 is 20. So 132 minus 20 upon 2, which will be equal to 112 upon 2. So the area of this triangle will be given as 56. Now let's move towards our seventh case, in which coordinates of the vertices of the triangle is given. So for example, if we have a triangle with sides A, B and C and its vertices given as XA, YA, XB, YB and XC, YC. So the area is given as like this, where XAYA, XBYB and XCYC are the three vertices of a triangle. So let's see an example first. So for a triangle with its coordinates or vertices given as 8, 4, 6, 9 and 2, 3, the area is given as XBYA minus XAYB plus XCYB minus XBYC plus XAYC minus XCYA upon 2. So putting the values of the coordinates, we will get like this, and simplifying it, we will get area that would be equal to 48 upon 2, that is equal to 24. So these were the 7 cases for which you can find the area of a triangle. I hope you liked our lecture. If yes, then do like this video, give your feedback in the comment section and share this video as much as possible. And if you like the concept of NoorulRiazi, then do subscribe our channel and follow our Instagram page with the same handle. So see you guys in the next video.